This is your pre-calculus 9.1.4 lecture. I think this is going to be part 1, and we'll have a part 2 after this. So 9.1.4, we're going to start using our matrices to solve systems of equations, and we can do them with paper and pencil if it's a 2x2 matrix, but we're also going to teach you probably in the next video how to just use your calculators. So I'm going to go through these first 2 problems, just walk through them quickly with you. 9-69, it says consider these 2 matrices, A, X, and, well, the 3, A, X, and B at the right. Write a system of matrix equations for A times X equals B. So this was before we went to break. We learned that you can go, some pointers, let's use this. You can go, do you guys remember this? You can go 9 times X plus negative 3 times Y. And then you can set that equal to 48. Well, see, so they put the 2 matrices next to each other because it said we have to multiply them. And then you go 9 times X plus negative 3 times Y. Remember, it was like we're trying to find this number, and this is in row 1, column 1. And this first one is my row matrix, and this is my column matrix. So my row matrix and my column matrix. So I don't know if you guys remember. I hope you remember this from before break. 9 times X, and then you go negative 3 times Y, and that's equal to 48. And then for this one, you would go, this 8 is in row 2, column 1. So this first matrix is always your row matrix. So I'm going to take row 2, column 1. So 1 times X plus 1 times Y equals 8. And so that's what they have here. So that's just kind of a little reminder of what we had been talking about before we went to break. So 9-70 is the one I really wanted to do with you guys, though. So it says use the system of equations at right to complete the parts below. So here they gave us a system of equations which I'm sure you could solve using substitution or elimination or something, because you guys know how to do this, but we're going to solve it using matrices. So you take the coefficients and you make a 2x2 matrix with them. See what they did here? There's the negative 4 and the 3. And then you make this column matrix with the X and the Y, and a column matrix with the answers over here on the right. Okay, and then so if I wanted to check, I could multiply this back out, and I'd have negative 4X plus 3Y. See? And so on. So hopefully you got that part. So there's my matrix equation. So if someone gave you a system of equations like this, you could turn it into a matrix problem where you have matrix, a matrix times a column matrix. So it says there's no definition for matrix division, and we talked about that. Discuss with your team what you can do to solve the matrix equation only using matrices. So since we can't, to get X and Y by themselves, we can't just divide both sides by this 2x2 matrix here, but what we can do is multiply both sides by the inverse of this matrix, because I don't know if you remember this, but before we went to break, we learned that you can get the identity matrix by, if you get the inverse of a matrix and you multiply it together. If you multiply a matrix and its inverse together, you get the identity matrix. And so it kind of, cancels it out. So we also, I think we already learned how, before we went to break, how to find the inverse matrix. And there was a little formula for that. So from here, I'm just going to get out. I'm just going to show you how to do this on paper. So what I'm trying to do is solve this problem by multiplying both sides of the equal sign by the inverse of this 2 by 2. So how do I get the inverse? Well, you might already remember this because we did this before we went to break, but I'm going to go ahead and go over it again. So to find the inverse of it, there's probably a math notes box somewhere that tells you that what you do is the top left and the bottom right, you let them switch places, and then these two, you just turn them opposite, so it looks like this. If I had A, B, C, D, I'm letting this diagonal right here, I'm letting the two components trade places, and then I'm just taking I'm changing the sign of these two. And then I'm multiplying this whole thing by 1 over the determinant. And you're probably thinking, well, I don't remember how to get a determinant because that was before break. So here's how you get a determinant. If I want to, I think you'll remember this, it's pretty simple. To get a determinant, you take the top left times the bottom right plus the bottom left times the top right. Basically, it's kind of like cross products, like you go this times this plus this times this. No, sorry, minus this times this minus this times this. I said it wrong. Look in your math notes box, though. So I multiply these minus these, and I get 2 is my determinant. And remember, in inverse, I have to do this little switcheroo thing on my 2 by 2 matrix, and then I have to multiply, like scalar multiply, each one of these components by 1 over the determinant. Well, I figured out what the determinant is. The determinant is 2. So that means I got to do my switcheroo. I'll call it the switcheroo. The switcheroo, where I take the bottom left and the top right and I let them switch places, and I change the signs of these two, and I'm going to multiply it by 1 over the determinant. Well, we just figured out the determinant was 2. So take that all in, and then scalar multiplication says I take this and multiply it by all 4 of the components. So this turned out to be 5 halves, 3 halves. This turned out to be negative 6 halves, which is negative 3. And this one turned out to be, well, half of 4 is negative 2. Okay, so this right here. Okay, now I did all that work. It solved this system of equations by multiplying both sides by the inverse. If I made my inverse correctly and didn't mess up, then when I multiply that inverse by this 2 by 2, I should get the identity matrix, which will just, when it multiplies with these, it'll just leave x and y by themselves. And then I'm going to multiply that same inverse matrix on the right-hand side. So that's what I have written right here. That's my inverse matrix. Okay, I unfroze. So sorry. So now, when I multiply, if you remember how to multiply, you go, I have a 2 by 2 and a 2 by 1. So I'm going, since these match, I'm allowed to multiply, and I'm going to come out with a 2 by 1. Okay, I don't know this yet. I've already done the problem, but we'll pretend I don't. To get these numbers, I have to multiply negative 5 halves times negative 17 plus negative 3 halves plus 26. Sorry, plus. So I did all the work right here, and it ended up being 3.5. Okay, and then to get the number that goes down here, that was 3.5. To get the number that goes down here, that's row 2, column 1. So it's this times this. So negative 3 times negative 17 plus negative 2 times 26. So I just wrote it down on scratch paper right here. That ended up being negative 3 times 17 is 51. Negative 2 times 26 was negative 52, so I got negative 1 here. So I just solved, so this is my x, and this is my y. So I'm going to quit this video because I think it's getting too long, but that's how you solve the system of equations, and it shows it right there. Now, I'm going to do another problem, and I'll call it part 2.